Hello. Hello.
Good morning.
Morning. Let me just quickly update a link that I think the one in Discord didn't have the password, was it?
Hey everyone.
Hi, Sebastian. How are you?
Hello.
I'm good. How are you?
I'm good. Thanks. Thanks for joining. Thanks
Yeah.
uh for taking the time to be
Yeah,
here.
good
Just
morning, good evening, depending on where you all are.
Well, hello, Sebastian. Thank you so much again, as Santiago said, for giving us this time. This group, we
Yeah.
spent the last couple of months poring over what your last book and your blog posts and everything else. So thank you.
Well, yeah, thank you. I wanted to say, yeah, thank you for actually reading the whole book. That is quite amazing. It's a long book. So yeah, thanks for, just seeing it from chapter one to the last chapter, basically. It's like, it's kind of a big compliment because, could easily say after chapter two or chapter three, that's boring or move on to something else. So yeah, thanks for actually completing the book.
Well, this is a very motivated group.
yeah, yeah. It is. It is. So yeah, just to say a couple of things before we actually start. Um, as we were saying, first of all, thanks. Thanks, Sebastian, for being here, and thank you for writing the book. And not just writing the book, also like for all the stuff that you share online, like on your magazine. It is amazing. Um, for those who don't know, but probably we all know, Sebastian, the author of the book that we were reading, Build the Large Language Model from Scratch. He is also the author of two other books that are quite fun. I've taken a look at this one, and this one I actually haven't, but it's on the list. And he's also the research engineer at a new research lab, if I understood correctly, right? And
Um,
writer of the magazine, formerly
yeah.
being, yep. So yeah,
Thanks.
as
Thanks for the kind introduction. Yeah, I just wanted to confirm this is all correct.
uh
Yeah.
this is all correct. Cool, nice. So yeah, we have quite a person with us right now to just take the chance and ask all the questions that we have. Just some house rules. If there's like some background noise happening, I might mute you just to keep the call sound pleasing. And just to go with order and asking questions, just feel free uh, to 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 raise your Zoom hand, like the emoji hand, and then you can ask a question. But that's it. Um, yeah, thank you. I don't know, Sebastian, if you want to say something before we start
Yeah, I mean,
conversation.
yeah, just really wanted to say thanks to, all the people who read the book. And also, like there are a lot of people who were commenting on GitHub, on social media. I'm not like the biggest Discord user. It's just, I don't know, I sometimes use it, but yeah, I'm like from a previous generation, maybe where it's overwhelming almost to me. But
Hmm.
I sometimes, also I do I think I have an account. I don't go often online, but on social media or GitHub and so forth, all the questions and every discussion, this is actually very motivating. Like yeah, might think, okay, this is like as an author, it might be bothering me, but it's not bothering me at all. It's the opposite. It's actually quite, motivating. It almost wants me to make more stuff. Like it's if there are questions like, oh, people actually care about these things, and it's actually super cool that you organized a whole study group around it. It's yeah, quite cool actually. It maybe is motivation to write a next book. Sometime if time permits.
Yeah, yeah. So yeah, maybe I can start with the first question, and then probably everybody else can go next. So apart from how are you, how's it going with everything, I wanted to yeah, to ask. Um, so I was while writing the bio, the introduction. I realized that you're no longer at Lightning, and now starting as a full-time position on what it looks like your own research lab. Can you tell us a bit about that?
Oh yeah,
Is it too
I
early
didn't.
to?
Yeah, yeah. I didn't plan to actually, talk about it that much yet. But
Mhm.
yeah, I can say a few words. So, I was in academia for like basically my whole life. Was a undergrad and then a PhD student, and then I was a professor at UW Medicine in the statistics department, and I like teaching a lot. So the thing is, you probably have noticed I like explaining things and teaching at the university. I had a great time, but it's a lot of responsibilities where you have to write grants most of the time. You have your own research lab, and you try to maximize the time you can do research. But then, yeah, you can also teach classes, and I do enjoy this a lot. So at UW Medicine, I was creating new machine learning and deep learning classes, and the thing was, after I think it was about 2, 3 years. It was also the weird COVID semester, I remember. I was
Mhm.
thinking, yeah, I do like teaching, but I don't know if I can teach the same class every year for like 40 more years, or maybe not 40, but like something like that, where it's like I was very motivated to teach it, but I knew I couldn't keep it up because it's similar, and I wanted to, do the next thing. And that was the time where, AI companies became really popular. I mean, I was working in this field for a long time, but that was like I was seeing a lot of people had a lot of fun, at startup companies. So I tried this. I was at Lightning. I had a great time, great colleagues, and I enjoyed it a lot. Um, but yeah, it was also the 3 year mark. So in both cases, I think it was about 3 years where I felt like, yeah, this was a really good time. I really enjoyed it. No regrets. It was honestly a really awesome time, part of my, experience in life. But then it's also time to maybe explore something new. So
Nice.
I'm trying to do, yeah, I mean, as an independent person now. I mean, it's new. I just something I started this year. It was my thing for 2025. So we'll see how that goes. So I don't want to share any, let's say, too many details yet, but
Mhm.
we'll be working on cool stuff, I guess. I will tell you
Amazing.
when it's ready. But yeah,
Amazing. Yeah.
so yeah. So, but I must say, like, it was really just because, I like to try things, and I had an awesome time in both university and at Lightning. In both cases, 3 years. But then it's also the time like I need I want to try something new. It's just. But yeah, I personally I still use the Lightning AI compute platform because I do think it's super easy to use, and it's compared to Colab, what we built there. Google Colab is great, but there you can do schedule jobs, multi-GPU computing. I was just actually using it the other day for some of my experiments. So it's not that I left because there was,
No, no.
something I was unhappy with. It was more like I just wanted to try something new. Yeah. So I'm still in touch with
Amazing.
my colleagues and stuff. So I plan to collaborate also still with them and stuff. It's more like, but as an independent person, basically. Yeah.
Amazing. Yeah, we'll keep an eye on what you are cooking. I see, Michael, your hand is raised.
Yeah, thank you. Yeah, and again, I just also want to say thank you, Sebastian, for the book. I really learned a lot. And I was kind of happy to hear that you said that it's motivating and that you might consider writing more. Because that was my question was, would you consider writing a follow-up book? And what I'm kind of thinking of is something that goes up to more like of the modern LLMs. Specifically like maybe like Llama architecture, and maybe even like some of the newer stuff like DeepSeek. I really like your teaching style, so it'd be great to learn more about that those technologies in the same kind of style.
Actually, this is a good point. If I may expand a bit on this. So you brought up other LLMs and Llama and everything. And so I started writing the book like 1.5 years ago. I think there was already Llama 2. That was what I was currently using, like also implementing. And the reason why I picked the GPT model is because it was the simpler. It's like the foundation, basically. It's like the original model in a sense, where that's where it all started. If you go, like, of course, there's the transformer architecture, but it's the first kind of decoder LLM. And everything from there is very similar, but like you said, there are nuances. And the reason why I was using it also is back then the Llama 2 license. I mean, it's a bit different for the Llama 3 license, but you do have to agree to the license terms. And I also know from experience, not every user, depending which country you are, or I don't know, it's sometimes you're depending on getting access, let's say through Hugging Face, and I wanted to try to keep it a bit more independent. But there are other LLMs like Olmo, which are, I think, have fewer restrictions, where you can download them without making an account somewhere and stuff like that. But that being said, is the other reason was I wanted to have the model as small as possible so you can run it on a laptop. But actually, I will also maybe something I can discuss in a follow-up question here or later, but how to make it faster and scale it up. But if I maybe I can share my screen here. I'm not sure if you've seen it. I wanted to share you something in my GitHub repository, in the books GitHub repository. If you don't mind, share my screen, Santiago.
Yeah,
Is
go
that
ahead.
possible? Or
Yeah,
oh yeah.
yeah,
Mhm.
I think you
Yeah,
should have.
perfect. Okay. So this is yeah, just the GitHub repository for the book. And maybe you've seen this already, but I did have like bonus material, GPT to Llama, where I actually walk through the process of converting this GPT model to Llama 2, Llama 3, Llama 3.1, and Llama 3.2, where it's all these little additions. So group query attention, I think for Llama 3, because for Llama 2, only the bigger models had it. So I'm focusing for each model family on the smallest one. So it's running on more hardware, like instead of, so see, that's a 1 billion instead of 105 billion, just to keep it small. But it's the same concept as with GPT-2, where it's just like changing these numbers here, like to scale it up to the 405 million model. And then, yeah, the new things, the main things are really, I would say, yeah, I mean, rope, rotational positional embeddings. Then, I mean, wait time was already in GPT-2 in a sense. But yeah, the rope and larger input context and grouped query attention instead of multi-head attention. It's like a efficiency tweak. And ARM S norm instead of layer norm, but it's just efficiency tweaks. CELO activations, or it's actually Swiglu. If you compare that together, this is called Swiglu. It's like little modifications, but GPT-2 is still, like, I would say, the foundation. And that being said, yeah, it would be nice to write this up more nicely, maybe a project for this year. I'm not sure if this is like a new book or it's just like the bonus material, like where I just write this up as a nice article or something. But yeah, so I do have like like a little step by step. It's not as polished as the book by any means, but if as an intermediate thing before there's a new follow-up book, let's say this might be interesting. So there was one thing where, yeah, I think it's legit to mention other architectures, like you said. There is a project, though, that you might also find interesting. If I go to my GitHub page and then go to LitGPT. So that's like an open source library I worked at while I was at Lightning. And here we did also implement a lot of LLMs. So like it's like the same idea, implementing things from scratch. And there is the model file here. And in this model file, it's based all on the GPT class. But yeah, there's lots of code for all the different special use cases. So all the code is on one class. But then you have the config files where you can see at a glance how the different LLMs are different. For example, I mean, there's all kinds of, I think there may be 30 LLMs in there, like stable LLM, there's 3. Yeah, so it's all kind of like you can see at a glance how they're different by the number of layers, number of heads, and stuff like that. Is this Llama? That's still a stable LM for some reason. Should be a Llama 3 in there though, somewhere there. Yeah, so you can see basically what's new, the new grouped query attention, and yeah, rope. And think there might be DeepSeek also, but only the distilled versions for now, I think. Yeah. So, but yeah, so that might be also a good supplementary material that after the book to look at the implementations there. It's a bit more advanced, I would say, because it tries to support all kinds of LLMs. But yeah, I don't know, it was probably way too much detail, but I hope in a sense this answers the question. But yeah, hopefully a new book one day. It took me 1.5 years to write the previous one, so it might be a bit, but I do like writing books, so there's probably gonna be a new book in the future sometime.
Mash, I see you have a question. Go ahead.
Thank you, Santiago. Sebastian, thank you so much for just that overview. And if I may ask you anything, as a couple of smaller questions, but one major big one, as your ability to pick up the research papers and to be able to teach and explain some of the most important innovations in foundation models, like as you just walked us through the Llama 3 implementations and so on, is just brilliant. And your recent blog post on reasoning models, that is perhaps the best source I have found in
Oh,
the
wow.
deep reasoning models so far, where you outline, everyone's talks about some of the other luminaries in our field, like yourself, mention, oh yeah, DeepSeek just did 2 or 3 optimizations over the Llama model and so on, right? You actually outlined it and you explained it very well. So thank you for that. So my question to you really is, the smaller one is, how do you motivate yourself? How do you get into deeper and deeper understanding of the models? What is your approach? Do you just pick up the research paper and study it and practice coding it, replicating it, trying to make sense of it for yourself? For us learners, we would love to know your mental model and your mental approach for keeping up with these breakthrough innovations and making sense of it. My second question is a little broader, and I'm happy to table it for a later time if you like, but it's the idea of foundation models and LLMs are important, but in practical applications, which is where I work, it's about the enterprise orchestration into work processes. How do you then take one model, and it's at the heart of that process of automating tasks, workflows, and so on. That's what's really valuable. So for me, working with the top companies and they're making their investments, the investments aren't on the models themselves, the investments are in the workflows. And would love to get your perspective on how you apply the models.
Okay, so these are actually really good questions. So the first one, let's start with a smaller one, maybe. Or they're both, I think, similar in a sense. Probably I can give an 1 hour answer for each, but in short, it's for the first one, how I would approach it. Yeah, honestly, it varies a bit, but it's kind of related to what I was just showing earlier, this LitGPT library, for example, where some models there, I mean, I mentioned we had like 30 models there. For some, it took me and my colleagues literally like a week, sometimes 2 weeks. It really depends on how much information is available. Often models don't come with papers anymore. So I remember for Llama 3, that I don't remember, it was almost a year ago how that went, but I remember well when I was trying to update it to Llama 3.2 that they changed something in the rope scaling. Like there was like some scaling factors they changed, and since there was no paper for Llama 3.2, it took me days to figure it out. You can probably tell by the PRs if you go back in the GitHub repository that I was like a lot of trial and error to get it right. The one way, it's a bit cheating, but the one way how I do this is also there's usually a reference implementation by the original authors. Often it's through the transformer library in Hugging Face. Now the transformer library, I mean, it's a really good and robust library. I would probably use that for, I don't know about production necessarily, but for really like good, solid application prototyping. I think that's like a good library to use. But the code is really hard to read. Like not the way you use it, but if you want to go, let's say, understand how they implemented the LLM, because it's such a big library and they also support so many LLMs. It's kind of like I mean, there's nothing you can do if you have like a library that size, but it becomes really like overwhelming and complicated and intertwined. And because it has been developed by so many people over, I don't know, 5 years or 10 years, where it's like, it's very almost messy to some extent for like trying to understand it. Now, so, but you can use the library. That's what I do also when I implement something to make sure I get exactly the same results. Like when you load the model, uh, if if the output doesn't look right, like you get different logits or something like that, then you basically go backwards. So then usually what I do is, oh, there must be a mistake somewhere in my code. So I do print out the outputs of each layer at this, like starting with the embedding layer, first transformer block and so forth. And then almost like a binary search, you kind of narrow down where does your discrepancy come from? Is maybe your group query attention module wrong? Did you maybe accidentally in the projection layer, it's usually the same input and output, like the dimensions. The input and output dimensions are the same. So sometimes one error could be is you accidentally forgot to transpose it, or you transposed it because the way the weights were saved. And so in that sense, yeah, you have to work kind of backwards and find where is my mistake, basically. But there's actually it's sometimes frustrating if it doesn't work, but if it works, it's very satisfying. But it is like a way to also self-check yourself if you implement the architecture and you load the weights. The first thing is the shapes have to match. You get a PyTorch error if the shapes don't match. That's your first way to make sure, oh, I understood it correctly. And then if the results still look off, if the LM doesn't produce correct results, then this approach where you check the outputs from each layer using a reference implementation. And yeah, and often if there's a paper, I love to read the paper to just get additional insights how they trained the model, because this code only gives you information about the architecture, but not the training. The DeepSeek paper was actually quite nice because they had a lot of details, but I must say also it requires a lot of patience. You mentioned my article, and I mean, you can share my screen again. I draw a lot of stuff also in actually just my slides, where I use the same when I give talks or make blog posts. I use the same tool because it's just faster for me. Because I'm not like an artist, so I'm like just that works for me. It always worked for me, so I'm just using what I find comfortable. But yeah, I made this figure to outline how they trained it, and it took me like I had to read the paper like 3 times to make sure I understood it correctly, because it's not that. I mean, it's pretty straightforward, the paper, but it's still not that easy to me sometimes. Depends, because it was quite the process. I was like, yeah, is that right? And I remember I had this article and I did have a mistake here. For example, I actually this arrow here, for example, I think in my original version I had it connected like this. I thought, for example, they took the R10 model and further fine-tuned that model, but instead they just used that to generate the data, and then they again use the base model basically. So it's like a nuance, but it's like, yeah, you have to read the paper sometimes multiple times to get these details right. I mean, sometimes it's because, I don't know, I'm not having a good day, I'm just misunderstanding things. Sometimes it's just because papers are written, by experts. For them it's clear, but for a general audience, yeah, there's maybe information missing. It's if sometimes if you don't understand a paper, it's not literally your fault. It's just, yeah, the paper was not written clearly or something like that. I wouldn't say that's necessarily true for this DeepSeek paper, but I often encounter this. I read a paper and I'm like, yeah, I have a rough idea what they're doing, but that's not enough information to re-implement the model. And in that case, that's where you have to look at the reference code implementations, and yeah, sometimes a lot of work, but it is also a fun exercise often, yeah, if it works, yeah. And to your second question, the implementation and workflows, yeah, so that is usually a bit above my, let's say, everyday work what I usually do. So at Lightning, for example, this was usually done by our customers themselves. We do have some solutions, but we developed a general compute platform where you can run your LLMs, you can host your LLMs, you can actually deploy an LLM as an API, and then you interact with it as like an API endpoint. I don't know if I have some slides on here, but probably, yeah, maybe this one. So, I mean, there's of course ChatGPT, but you can host your own. I don't know if this actually plays. Yeah, so in LitGPT, for example, I implemented LitGPT Surf, and then you can just surf an LLM, and then it becomes like an API endpoint. And this is on a different machine. For example, you can, with a JSON query, you can query it and then do something with it. But that was usually the level where I stopped. I didn't go beyond and build a full scale application like a legal chatbot that customers can subscribe to and then gives you legal advice or something. I never did anything like that. I just that was as far as I went in terms of applications. So yeah, I mean, customers that we had, they are probably using the LLMs for applications, but yeah, I wouldn't be allowed to share the information there, unfortunately. Yeah. And I also should add, there's maybe a related question. Should you use or should you run a local LLM versus, let's say, using an API? And I think it depends. There are like different advantages and disadvantages. So for the book itself, I would say this is for educational purposes. So I would probably not use this LLM for any real application because, it's still just a GPT-2 model. You can build a very powerful classifier like as shown in chapter 6 where this might be sufficient. But I would rather use a newer LLM, Llama 3.21 billion, if the license terms are okay with the company you're working at. Or let's say DeepSeek, if it's a local one, if it's allowed to use it in terms of other restrictions. But yeah, the advantage of running a local LLM is you can use it with sensitive data, like some data that is not allowed to leave your computer. Where if you use something like just naming random names, but ChatGPT, Gemini, and Claude, they have privacy policies, but still, you might not be allowed to just use it and upload customer data there or something like that, because the data leaves your computer and then is on a different server, and different contexts have different limitations. So in that sense, I think it depends on what the restrictions of your business application are. Is it supposed to run local or online? And because of privacy, the other one is also convenience. For example, I have a phone for like 10 years, and I feel like it's getting the Siri on function on the phone is getting like worse and worse, in the sense that not that it qualitatively gets worse, that's true to some extent too. But I remember 10 years ago when I was driving and I didn't have good cell phone connection. It still worked in a sense for rudimentary things. I actually only use Siri when driving because then you can do a hands-off approach. I like usually typing, but for the driving, I know when I had a note to myself, sometimes it worked offline, but it doesn't do that anymore. You have to be always online, even if for simple things. And that is, I think, also a big restriction where I feel like it would be so cool if, you're driving somewhere, you get lost and you say navigate home or something like that. And it doesn't need internet for that because the map is downloaded. I have actually an offline map, but it still doesn't do my request. It says, sorry, no connection or something like that. And in that sense, that is where it makes sense to also have local. I mean, Siri is not LLM based, I think, yet, but they are planning to do that. But they do have these Apple Intelligence features that can work offline for privacy reasons. But I think also because that just doesn't require internet. It's offline. But then, yeah, it's a trade-off. The performance is not as good. It might be faster, but it needs more hardware, and the performance is not so good. And one other thing to consider is even for, let's say, Llama 405 billion. When I ran this on a server, I needed 8 A100s, the 80 gigabyte version, and this is like $15, $20 an hour. And if you run this for a day, let's say just the workday, 10 hours, yeah, you pay $200 a day just to run this model, even if you don't use it. And so, it might not be always even cheap to do that, where it might be just cheaper just to use an API like ChatGPT. So it's something to always consider. Yeah, lots of conditionals here. Yeah. Yeah, good questions. I hope that kind of answered it a bit, but yeah.
It was. Thank you so much for your genuine candor and openness. Truly appreciate it, sir.
Yeah, thank you.
Michael?
Yeah,
I see
sorry, I
your
don't want to
hand
dominate
right.
things.
Yeah.
Yeah, I
No,
don't
no,
want to
it's
dominate.
okay.
I already had a question. But it actually reminded me when you were talking about chapter 6. That was one of the chapters I actually did a presentation on in our study group. So I went through the code quite a lot. And one interesting thing that we found was maybe it's better if I quickly share my screen and I can quickly show you what I mean. But we at the end of the chapter, we actually test out this classifier model that we fine-tune. And one interesting thing that I picked up because I was typing out the code is that if I have these two examples here where if I just leave out a period, so like here it has a period and it classifies it as spam, and then if I leave it out, it classifies it as not spam.
Ah.
And I thought maybe I did something wrong. So I went through your notebook in your GitHub repository and I saw the same thing there. So that was interesting and I never really quite understood why that could be happening. So I was curious if you had any idea of what that could be.
Yeah, I think it's a very good point. I think it's overfitting, due to overfitting where the data set was relatively small. And it's like a hypothesis but I'm suspicious, not suspicious, but I have like, I would say it's likely because a lot of so this one is not spam. Probably a lot of the spam data had a lot of exclamation marks or I mean, maybe it's not true, but I think it's just due to overfitting that more. Although here it's a counterexample in text too, because you have exclamation marks and question marks, but maybe more periods in the spam examples, and then it's just overfitting it, I think. I would be curious as an experiment if you just remove all, or you add a period to each example, or replace all those question marks and exclamation marks in the data set by periods, so that each example has a period in like there. And curious if that would still occur as like a little fun experiment. But I think it's probably due to overfitting because it's a very small data set. Yeah, because one of the things for the book was I wanted to use public data sets. So this was like something that's publicly available. Also for chapter 5, I didn't want to use, any copyrighted data. So it's only like a small open source, open public domain book. But I think if you do this on a real bigger data set, like 50,000, 100,000, I think this would probably not be such a big issue. Yeah, and I think also one thing I'm not doing in the book, but if you use something like ChatGPT, I mean, no one really knows except the people that know OpenAI what exactly they are doing, but I'm pretty sure they also have tools to clean up the input where like correcting spelling mistakes, like simple ones, and also maybe punctuation, but I'm not sure, but like where this is more like on the API layer level compared to having the LLM do all the hard work. So here, for example, one could run a regex, a regular expression, to replace all special characters by something else, or something like although the special characters or things like that could also be, of course, a hallmark of spam. So it's yeah, it requires more application specific engineering and tinkering, I guess, but it's a good honestly, it's a really good observation. I think it's in this case literally overfitting. One thing I wanted to try is also there was by Jeremy Howard a new paper, Modern Bird, just as a comparison how good that is, like encoder decoder LLM, because they are usually used for let me share my screen. They're usually used for classification tasks. I did have a bonus material section here where I ran different experiments, like like training different aspects of the model, different sizes and stuff. But I also compared it somewhere to BERT. Let me see. Oops, chapter 6 again. Oh yeah, different data set here. This was for 50,000 examples, the IMDb movie data set, movie reviews. I tried the small model. It got, what, 92% accuracy. The BERT model from Hugging Face got actually less. Yeah, and this one, this is the still BERT. It got 91. So I think, yeah, this one is more overfitting, is my guess. Oh no, this is also pretty large gap. This one too. Yeah, I think it would be interesting to also try modern BERT, but in general, I think in your case, the data set, or in the chapter 6 case, the data set was too small. But it is a very interesting point. I should probably, yeah, consider if there's a new edition in 1 or 2 years using a bigger data set. But then it's again takes longer to train, and then it won't run on a laptop anymore. It's like a delicate trade-off to make something useful, but then also make it work on multiple computers. I hope this answers your question, though, to some extent.
No, it does, and that's a good experiment. Your suggested experiment of adding the peers and then retraining. So that's something I'm going to try, and I'll report back. And
Yeah,
I
I'd be
think for me,
curious, yeah.
the good lesson there was that you should always look at what the model's doing on some actual data, not just like look at the metrics.
Yeah, that's a good point, especially for LLMs, where even if you consider general evaluations where people report MMLU is for some reason the one thing everyone reports still, and it's essentially just multiple choice question answering. It's like there are 4 options, A, B, C, and D, and it's just whether the model answers correctly, but it's not in most cases how people use LLMs, right? So it's like, yeah, there are other evaluations like the Alpaca eval or different leaderboards, but yeah, it is tricky. Evaluation is really tricky actually. It's not trivial because it's not just usually something you can report with a simple number. Yeah.
Yeah. Mayank, I see your hand. Is that right?
Yep.
Yeah. Go ahead.
Yeah. Thanks. So, like, as a fellow independent ML consultant, I kind of understand the journey you're on, Sebastian. And like, my query is, given your insights into the field, how feasible do you see state space models becoming the next standard for sequence modeling over transformers? And what are the current advantages and limitations of SSMs and hybrid models, like Mamba and Jamba, in practical applications?
Yeah, I remember, I mean, I haven't really, I must say, with a big disclaimer here, because I haven't really followed state space models that closely. I remember the first ones, I think it was Hyena Hierarchy or something like that, one of the first ones, and they focused more on DNA sequences. Their selling point was essentially that you can do million tokens and stuff without, having the same scaling issues as LLMs have. I mean, even the 1 billion Llama model, the Llama 3.2, it has 130,000 tokens input, but supporting that input doesn't mean you can trivially use that. It requires a lot of memory. And yeah, with the state space model, the appeal was, yeah, you don't. But then I think the weakness was really that the condition on the previous input. So I don't think the original state space models had that, like the self-attention mechanism, where it was referring to all the other tokens. I mean, this is like a trade-off. You make it more efficient this way, but then you lose context. And I think for certain applications, that's fine, but I do think, yeah, it's a trade-off. And what I've seen in recent months is more like people moving towards hybrids. Like you mentioned one, Jamba. I think there was also Samba, Jamba. Both of them have attention mechanisms in there, I think. So it's kind of like meeting in the middle always, almost, where you have the original state space models, the pure state space model, on one end for just super efficient sequence processing. Then you have transformers on the other hand. And then, yeah, both have trade-offs. And so they kind of meet in the middle, I would say, by having these hybrids. But that is, to be honest, all I can say, because I think there is no real deployment big state space model that is being used for, let's say, chatbot purposes. I think in the papers they usually compare to small 1, 3, 7 billion models, but there's nothing on the scale of I don't know how big GPT-4 is, but let's say, or DeepSeek, let's say on the scale of DeepSeek, 670 billion or even closely to that. So I think no one really knows how they behave, the state space models, if you train them on 15 trillion tokens like DeepSeek, for example. So for small applications, I think it makes a lot of sense if you process long sequences. But yeah, I don't know about what the future holds. It's interesting because I think the transformer architecture is so old that yeah, it's maybe time for something new. But I don't know if state space models are the new thing or if transformers are fine and people keep just improving the efficiency there. Like, I mean, there are tricks, KV caching for inference. There's the multi-query attention, mixture of experts, like all these modifications to the attention mechanism where people get performance this way compared to moving to state space models. So it's an interesting question. I don't honestly know what the future holds. Yeah, but something I'm keeping an eye on. But yeah, I must say I'm not an expert in state space models. Yeah, but I find it just sometimes interesting to see what's going on there. Yeah.
Cool, thanks.
I see Eddie. I don't see Eddie now.
Sorry for the background noise. I'm in a conference in Amsterdam right now. Thank you, Sebastian, for your time. Highly appreciate it. I learned a lot from your book. I have a question. So we say when we make fine tuning with LoRa, for example, it's said that all the existing weights are frozen. And I noticed that I fine tune multiple Llama models. And my expectation was that every time I make fine tuning, let's say with some specific domain data like networking, I don't expect the model to be able to provide me answers from the previous pre-fine tuning data. Can you please elaborate a little bit, Sebastian, on what exactly means to to freeze the weights, and what is the impact? I mean, if I make a fine tuning, how much information the new fine tune model will use from the foundational model? Thank you very much.
Yeah, that's a good question. So, yeah, there's LoRa basically, where I mean, it depends, but you could apply to all layers. You can unfreeze layers and just train some layers together with the LoRa weights, or you can just only apply freeze, like you said, the standard approach, freeze the whole model and apply LoRa adapters to some layers. Actually, I think also based on the paper, the Apple Foundation model paper, they do use LoRa on the phone basically to for specific use cases. I don't think they go into detail. So this could be either for making the model specific on your device to your behavior, or it could be just switching LoRa weights for different applications. If you have, let's say, translating text, summarizing text, answering questions, that for each you have different LoRa sets of weights where you keep the original model untouched. Now, but the thing is, that's the question you asked was if the model loses the knowledge, and when I answered correctly. And I think, I mean, it's tricky because I think LoRa is usually used for instruction fine-tuning, so compared to knowledge fine-tuning. And usually LLMs take up new knowledge better during like regular pre-training compared to instruction fine-tuning. It's just something I've heard of people saying or observing when, I mean, there are also papers, for example, if I share my screen, let me see, I think it was called LoRa learns less and forgets less. There was a paper where they studied this, and it's like a trade-off. Here they actually found that LoRa forgets less than regular fine-tuning, I think, if I remember correctly. They had a few plots here showing this on different domains, I think math and code. Yeah, math and code and math. And I would have to look at this again, but I think this one is full fine-tuning, so it actually even forgets more than LoRa, but even LoRa forgets some of the original knowledge. Typically, how it's handled, there's like a paper on continued pre-training. How you prevent or mitigate this is by, when you fine-tune the model, what you do is you include some of the original data back in the fine-tuning. So like I think they experimented with 1, 3, 5%, 10%. I think 5% was sufficient when you just keep 5% of the data when you train it further. But it's still, yeah, I think that's the problem with not even LLMs themselves, but deep neural networks in general, that they tend to forget. It's called catastrophic forgetting. So if you train it on something new, they might forget what they were previously trained on. And that's, I think, also one of the reasons why pre-training is a multi-stage process now, where they first train on all the data, then they do usually long context training, and then at the end they have, even a DeepSeek paper, this high-quality training, where they train on high-quality data last. And that is, I think, to just really, make the LLM as good as possible, just to get it used to what you really care about. Not like, because basically you put the garbage data first. I mean, not garbage that's filtered out, but like the not so good data first, and then the high quality last, because it's usually more, I would say, pays more attention to what it has seen last in that sense. It doesn't completely forget everything, but there is some forgetting. I mean, even as you can see here, it is getting worse at these things if you train it on something else. So there's no perfect solution, I think. Yeah, unfortunately, yeah. You can only reduce it, but I don't think you can fully get rid of it. It's like almost like this no free lunch type of thing where you can't have everything, basically. Unfortunately, yeah.
Yeah, thank you very much, Oscar.
Yep.
Rodrigo, I see your hand.
Yeah, thank you very much. Nice to meet you, Sebastian, and thank you. I want to thank you, Santiago, as well, for the whole organization of this. So taking the time of putting this together is hard sometimes. But I know it. So thank you very much, Sebastian, as well, for the your space and open to discuss some things as well. This is really important. And one of the things that I mean, this is not a technical question. This will be more based on your experience. Let me explain a little bit. So right now I'm just um about to start a laboratory of artificial intelligence in my country. So one of the things that I just want to get focused as well is based on your experience. What are the top three things that you say you get to focus on this in order to make it successfully? Successfully, what I mean is not only receive grants, because that would be like the paperwork, but what I mean is the publications of the papers, right? So the ideas or the documentation, and working as a team. So it would be great if you can just shoot a couple of advices. That would be awesome. Appreciate it.
Yeah, so it's a really tough question. It's a really cool thing that you are doing this. It's actually really cool to build up a lab in your country that is focused on AI. I think everything I say must be taken here with a big grain of salt, because I was not always good at writing grants. Because the thing is, that's the paperwork, of course, but it's like this. It's almost like it's like very formal, and it's of course it's good, but it's like there's like this whole tradition behind it, and you have to have connections with this person to do it in a certain format. And it's like I was never good at this, but I think networking is probably going to be important for that. Like I just this is just something I observed when I was at university, that having a good network is always really important there for this type of stuff. But when it comes to the work, for me it's usually there are things that are popular, and one things, well, sometimes you might think, oh, I should work on this because it's so popular. But then I think what has to come together is also that you're really interested in that. Like, if I noticed also, if I work on something I'm just working on because I feel like this is a good opportunity to get funding or a grant, then it's usually not that successful always. It's because I don't put 100% into it. And I think it's like picking a sub area where, because AI is so big, a sub area where you really care about that sub area, is my opinion. I think the other thing is I would probably not do pre-training. I mean, it's very general advice, but it's almost sad where people, I mean, it's cool for the community that there are so many open weight models being released, but I also sometimes feel bad for the developers, both academia and industry, who develop these models, spend millions of dollars and think they are really doing something awesome for the community, which they do actually. They do something cool when they have these open weight models and share the details. But the sad thing about it is like 2 months or maybe 2 weeks later, someone does the same thing and their thing is slightly better, and people will forget about your thing. And you spend half a year on that, millions of dollars, maybe sometimes in training, and it's obsolete after 1 month or something. The thing is, if everyone thinks like that, we won't have any open weight models anymore, which would also be sad. But yeah, I don't know. That is, I think, the sad truth. So I think almost like focusing on something more specific. It comes almost back to an earlier question where I think who said I forgot the name. Was it Mesh? I think Mesh, you said something about applications. I think yeah, it's almost like getting more specific and implementing something or doing research on a subfield might be interesting. Like where yeah, it's not. I would say you build expertise in that area. If there's a new LLM coming out, for example, you adopt this LLM rather than having to start from scratch again, where you have a curated data set, a curated evaluation set, and you can iterate on that and make progress, and then just swap out the LLM or tool and apply your pipeline, your methodology to that one, where it's not completely obsolete almost. But that is as much advice as I can give, because it's a big field. There are so many different things one can do, and I would rather focus on the post training rather than, let's say, pre-training as a general advice. But yeah, there's also a lot of nuance and there's a lot of techniques even within post training.
Great, appreciate it.
Great advice. Good. I great advice related to the comment on fine tuning. I never thought about that, but actually it makes a bit sense. Yeah. Taha, I see your hand.
Yeah, first of all, I would like to thank Santiago for conducting this meeting. Secondly, it's very overwhelming to see Sebastian. I've been following you for the past 3 years, and the first time I learned PyTorch was by reading your book named Machine Learning with Scikit-learn and PyTorch. So it's great to see you in person. Not in person in a meet, but still to see you. So basically, my question is a little bit like I'm in a dilemma right now. I started working in ML three years back, and at that time, the work was mostly related to PyTorch or MLOps, deploying models in production. Now, for the past 1 to 1.5 year, like there is very less work in those core fields, and more of that work is in deploying OpenAI API, Claude API, using these models in various automations. So it's been a year, and I have almost forgotten basics of PyTorch. Like this book made me realize that was the core I was wanted to work in. So the question is like a bit strange, but the current requirements in the market are related to using APIs and building the products, and the core things, core MLOps, core PyTorch is not yet in demand. So what will be your advice in that? Should we keep on working and finding work on those fields, or we should maybe I would say start working in what's in demand right now?
Yeah, that is a good question. I'm always, I must say, really bad at giving career advice because it's tricky to really know what's happening in 2 years or 4 years. It could be totally the wrong path. So please take this with a grain of salt and maybe don't do what I'm doing, like what I'm suggesting. Maybe it's wrong. I don't know. I don't want to be responsible for any, things there. But I mean, I'm saying this like jokingly, but honestly, it's like I would be sad if I would give bad advice. You just follow my advice, and then it doesn't turn out the way I said or something. Because I honestly don't know. It's just speculating. But I think I do think there are multiple levels to that really, where I mean, application, like it's kind of related to what I said before, that just doing what's popular. A lot of people are doing that, and if you are not super excited about it, you probably won't have you wouldn't be enjoying it as much compared to working on something you are excited about. Of course, there's always the need for, making a living, of course, right? And building a career. And so it's kind of like a tricky balance. But I do think there's also room for both, where both things can be combined in a way where a lot of work can be where you can use APIs like ChatGPT and focus on the application building, but the application usually also requires more than that. Like even like building or writing code to query the API in the way you need for your application. That is also already like a lot of coding work, where the API calls are just part of it. And there are usually not just one, but multiple models being used nowadays. I think even for like, ChatGPT in the back end, they probably run some Python, PyTorch stuff to do certain things. Like, but for even like transcription services, they use probably OpenAI Whisper to, if you upload, I don't know if they do audio yet, but if you upload a clip and you ask it a question about your video or clip, they probably use PyTorch tools behind the scenes too to extract certain things. So it's like, I think all the programs nowadays, they're like a hybrid, where part of the code is based on APIs, but all the surrounding stuff is not just APIs. With PyTorch, it's an interesting one. I don't know exactly what the percentage is of deployments like actually using PyTorch. I think it's still more like a R&D tool. It's the most widely used deep learning library, but I think it depends on what scale you operate on. But usually all the models are, I think, trained in a sense or developed at first in PyTorch. Maybe if you are big as DeepSeek, or if you're training Llama 4 and 5B, they probably use PyTorch to train the model first, like a few iterations, see that loss converges and everything. And then maybe they export the model. I mean, there's Torch compile, but maybe they export the model then, but then they do optimizations directly in CUDA, because then you can, I mean, if you save 1% and it's like $100 million model, it's $1 million you save by just optimizing it further. And so I think PyTorch will always be relevant to get you to implement the first version, and then people will probably optimize it with that. But then at the same time, there are also tools like Llama CPP or Llama, where it's directly in C or C++ or CUDA, where you skip the PyTorch part. But I think these tools wouldn't exist if there was no PyTorch, because the models were initially developed in PyTorch and then exported. And I do think this is also, depending on what company you work at, this is also, I think, going to be relevant still, where you don't maybe necessarily do everything in PyTorch, but PyTorch is still part of the workflow, where you want to improve the model, for example, you don't know, like there was like just the other day Tulu 3 or something like that, where it's like they took the Llama 3 model, the 504B model, fine-tuned it, and then now it has better performance than DeepSeek version 3, where I think this was largely done in PyTorch, like to get these steps implemented. Don't know if the final model, I have to read the paper actually, but I don't know if the final model was trained in native PyTorch, but I'm not 100%, but pretty sure the prototypes were in PyTorch. And in that sense, depending on the company, you develop it like that, and then you deploy it as an API. Like the same with DeepSeek. I think the models were in Hugging Face. You can use it in PyTorch, and then in addition, they have the application where they use an API. I don't know how they run the models, but then you interact with the API. So I don't think PyTorch will ever be not in the next 3-4 years outdated or something, or not in demand. I think it's always going to be relevant. But yeah, I think it's probably good to do also what you love doing, and yeah, because then you can really be successful and happy. I hope. Yeah.
Thank you, Sebastian.
So we're in the end of the session, but maybe there's space for one more question that I see.
Oh yeah, sure.
Yeah. Okay. Carlos, go ahead.
Hello, Sebastian. Pleased to have you here. Well, my question is a little bit ironic because we're talking about LLMs, and my question is about making them smaller. There is a trend of trying to make a large language model as efficient and small as possible. And my question is if first, if you think that there is any kind of structural or architectural limitation, or how far can we go in that route? How far can we go in making them small while still having something that is production ready, where we can sort of do one-shot training and those kind of things? And also the other question is about what is the best architectures that you think that we have right now for that kind of models, for making them small?
Yeah, so these are good questions because in recent years, I mean, looking at the original Llama 2 model, it was like 7 billion and 70 billion or something like that. And now it's expanding in both ends. So you have 405 billion and 1 billion. And also with DeepSeek, you have this big model. And I think that there's a trend towards doing both. You do the small model for on-device work, but then you have the large model as a reference point, like what is the state of the art? So you develop the large model as the state of the art, and then you, in retrospect, develop the smaller model based on the large model. So you kind of almost need both because you almost can't develop the small model without having that large model. And right now, how most people do it is essentially distillation. Back then, originally distillation meant that you train the model on the new data, the small model on the new data set, plus the logits, like the last layer outputs of the teacher model, the large model. Nowadays, when you look at, I think, the Llama paper, Gemma, and DeepSeek, I think they did, for DeepSeek for sure, but also the other ones, they did distillation just on the data set. So that means it's essentially instruction fine-tuning. It's just that the data is so much better that they use a large model to generate the data and then fine-tune the smaller model. But let me double check. But I do think I have a slide on this, I think, where I compared, I mean, they didn't have it directly in the paper, I think, but yeah, here, let me share my screen. They had to paste the numbers on top of each other. Yeah, so they didn't have the R1 and R10 in the same table, but they are not too far off. So they have like these distilled versions. So if you look at the Gwen 32 billion, I mean, it's again just a number. And like we talked about before, numbers, there's caveats that might fail totally on certain tasks. But if we just trust the number for now, you can see it's not that much. I mean, 79, 72, and here 94, 97. So these distilled models are not bad, but yeah, of course you will lose performance and quality. Yeah, but I think that is always like, yeah, no free lunch. You can't have a model that is small and just as capable as the large model. But you can do cool things, I think, with 32 billion. If you go smaller, 7B, you can see there's a big, or 1.5, there's a big difference. So for reasoning models specifically, I think 32 is maybe a good sweet spot, where if you go much smaller, yeah, that's maybe too small. So it's tricky. Depends also already on how good your base model is. You can see that Llama 8B and 7B, they're in the same size realm. This is slightly worse though than the 7 billion model. Here it's better. Yeah, it really depends. I think it's not a one size fits all. Even though if you look at the 70B, this one is slightly worse than 32B. It's always like, I think, going to be a function of how good is the base model, the small base model, and then also how good is your data. Here they only trained on 8,000 examples. I mean, only in quotation marks, but yeah, it is still impressive. And I think I mean, recently we have seen here they have O1 mini, there is O3 mini, and this is just speculation, but I do think these are also distilled models like O3 mini. I think there's a O3 model, and then they just distilled it to make O3 mini to make it cheap. Because yeah, the advantage is these are really cheap compared to the big models. But yeah, I don't know what the theoretical limit is, how how far you can go, but depends on the application. For reasoning, maybe you need slightly larger models compared to a model that just summarizes text or translates text. Yeah, I know it's not a perfect answer, but I hope it's at least somewhat useful.
Yes, it is. Thank you.
Awesome. All right. I think we're at the end of the session. Thanks. First of all, thanks, Sebastian, for joining. It was a pleasure. And also thank you all for joining as well, for joining the study group and for taking the time of a Tuesday and be here with us.
Yeah, thank you everyone for coming to this meeting, all the good questions. I had actually a great time. It was a lot of fun, and it's morning here, but it's a great way to start the day actually.
Yeah.
So it was quite fun. Yeah, thank you.
Yeah. See you.
Yeah, everyone, have an excellent night, evening, and morning.
Yeah, have a good rest of the day, everyone. Bye.
Yeah, good rest of the day. Bye. See you.